You're standing in the middle of nowhere, 10,000 years ago. The sun just went down, and the world went completely, totally, terrifyingly dark. No streetlights, no phone screen, no candle. Just you, the night, and every predator that has ever loved the dark. You look down. Under your bare feet is nothing but dirt, mud, dust, clay, and rock, as far as you can see, in every direction. Someone, and we are absolutely not asking who, has just given you the most absurd mission in the history of human civilization. Make a light, not a fire, not a torch, an actual glass-enclosed, wire-connected glowing light bulb from the ground you're standing on. You stare at the dirt for a very long moment, and then you start to understand something that will take the rest of human history to fully prove. Everything you need is already here. You just have no idea what to do with it yet. Step 1, you already know this part. Don't die. You cannot invent anything in the dark if something eats you first. So you find food, you find water, you learn fire, which given your current problem, feels like a cruel joke. You survive. Weeks pass. Then, for the first time, something wonderful happens. You have free time, and free time is the only ingredient that has ever actually mattered. Now you can think, and the first thing you think about, staring at the cold, dark ground, is that you need to understand what light actually is. Not poetry, not magic, physics. Light happens when something gets so unbelievably hot that it stops just being hot and starts being bright. A fire does it. The sun does it. The question is, can you make something thin enough and hot enough and protected enough to glow steadily inside a sealed container without immediately burning to nothing? The answer is yes, but the road from dirt to glowing bulb is longer and stranger than you can possibly imagine right now. The first thing you need is something to burn inside the bulb. A filament, a thread of material so thin and so resistant to electricity that it heats up white hot instead of just letting the current pass through cleanly. Metal is too easy to melt. Wood burns too fast. But carbon, pure concentrated carbon, can handle extraordinary heat without giving up. And carbon, it turns out, is hiding inside every piece of wood you can find. You just have to cook it out. You pile hardwood, oak, beech, anything dense, into a mound. You cover the whole thing with wet mud and clay, sealing it from the air. You light it from a small hole at the bottom, and then critically, you don't let it breathe. Without oxygen, the wood can't fully burn. Instead, it slowly bakes. The hydrogen, the water, the gases, all of it bleeds out through the mud. What remains when you finally crack it open, days later, is black, brittle, and almost pure carbon. Charcoal. You just made the ancestor of Edison's filament from a pile of wood and a layer of dirt. The same process people have used since 4000 BC, and the same carbon that will eventually glow inside a glass bulb and light up an entire city. But raw charcoal is chunky and fragile. You need a filament, a single, hair-thin strand of pure carbon, uniform enough to heat evenly without snapping. So you take plant fibers, a cotton thread, a thin strip of bamboo, something organic, slim, and consistent. You bake it the same way you bake the wood, slowly, sealed from oxygen, until it carbonizes into a black thread of almost pure carbon, fragile as a whisper. But that thread, if you protect it from the one thing that destroys it, will glow. That one thing is air. Here is the problem that stumped every inventor for decades. The moment your glowing filament touches oxygen, it burns out. Instantly, completely, uselessly. So you need to seal it inside something. Something transparent so the light can escape. Something airtight so the oxygen can't get in. Something that can survive the heat radiating from the filament without shattering. You need glass. And glass, as it happens, is hiding in the dirt right under your feet. Sand, ordinary, unremarkable, gets between your toes. Beach sand is mostly silicon dioxide. The same silicon that runs every computer chip on Earth was just sitting there being stepped on for all of human history. You gather it. You add two more things from the ground: limestone, which you get by heating seashells or white rock, and soda ash, which you pull from the ashes of burnt plants. 3 ingredients, all from the earth, all free. Now you need heat, serious heat. Sand melts at around 1,700 degrees Celsius, which is hotter than molten steel and far beyond any ordinary fire. So you build a proper furnace, thick clay walls, bellows to force air in and drive the temperature up, charcoal burning at the core. You feed your 3 ingredients in together. You wait, and then something almost magical happens inside the furnace. The sand dissolves. It stops being sand. It becomes a slow, glowing liquid that moves like thick honey. You pull a glob of it on the end of a clay pipe, and you blow, gently, steadily, while rotating the pipe. The liquid glass inflates like a bubble. You shape it. You cool it slowly, carefully, because cooling too fast makes it shatter. What you have, when it's done, is a small, sealed, transparent glass bulb, made from beach sand, made from dirt. You should feel incredibly proud right now. You really should. You should not feel completely proud yet, because a glass bulb with a carbon filament inside it is still completely useless if the air inside destroys the filament the moment it glows. You need to remove every molecule of air from inside the bulb before you seal it permanently. This is the step that broke inventors for decades, the vacuum. Getting it right is the difference between a light that glows for 2 seconds and one that burns for 1,000 hours. You build a pump, clay, sealed leather, a one-way valve made from thin animal skin. You attach it to the neck of the bulb and you work it, slowly, patiently, over and over, pulling the air out in tiny amounts with each stroke. It takes hours, maybe days. You can never get it perfect, but you get it close enough. Then, while the pump is still pulling, you seal the neck of the glass with flame, trapping the near vacuum inside, forever. Now all you need is electricity, which, in your case, means going back to the beginning of everything and discovering that too. But let's say, for the sake of your sanity and this video, that you've already been through that journey. You have a source of electrical current, 2 wires, a battery made from metal and acid, or a generator you built from copper and a spinning magnet. You thread your carbon filament between 2 small copper wires inside the bulb before sealing it. You connect the outside ends of those wires to your electrical source. You hold your breath. The current enters the bulb. It hits the filament. The filament resists because that's what it's designed to do. And that resistance generates heat. More and more heat. The filament climbs past red, past orange, all the way to a fierce, brilliant white. And because there's no oxygen inside the bulb to burn it away, it stays there, glowing, steady, warm, alive. You have made a light bulb from dirt.